More seriously, I probably would have tried writing my test cases before developing the code. I think that would have kind of identified some of the flaws earlier on.
But you did that in the concept code, didn't you? You wrote the test cases along with the code.
Right, right. But I would typically, okay, I'll add in this method, and then I'll write a test to do this, and then it kind of turn out, oh wait, maybe I should tweak that a little bit.
Right.
So maybe kind of writing the test cases first to avoid some work certainly would help.
Has anyone shown any interest in this work at this point?
No, not really. But
You're just too far ahead of the curve.
No, not that. I really haven't made it too public or tried to promote it either yet. So.
Cove?
Oh, the name? I picked that after my the name of my hometown, actually, Shady Cove, Oregon. So I figured it was as good a name as any.
So see, it's not an acronym. That's important.
It is not. It is
See,
not.
Back to what you might have done differently, would you have done the simulation? Because I guess it verifies in a way your other work, but it was a lot of work in itself.
Yes, it was an incredible amount of work. I think I still would have done the simulation just because to actually kind of be able to execute the code and get a result really shows a lot. Whereas if I were just to define interfaces and write some kind of abstract code against it, you don't really. I guess I would say I would still do it because it allowed me to get my hands dirty and see actual results, see it running, debug the problems that I made to kind of get a much more firm grasp on just the nuts and bolts of quantum computation.
Over letting some other student find your problem.
What was that?
Over having some other student follow on and find out the problems
Yeah,
that you found.
definitely.
Is there another simulation out there somewhere already?
Yeah, there's several simulations, all to varying degrees. Some focus more on simulating the quantum computer, not actually programming it. So it might be a visual interface where you drag operations onto kind of a series of qubits kind of thing. So there are other simulations.
But still, you needed to make your own. I mean, you couldn't have reused the existing ones.
Yeah, that probably would have been more work even to try to reuse existing ones. Any other questions or comments?
I was hoping David would have a question at this point.
I do have a question. The physical resource limitation that you hit in memory, do you think that that was a result of the programming algorithms themselves of addressing the qubits and doing the matrix and all of that? And if you use the mathematical language as a substitute somehow, can you reduce the amount of resource usage, do you know?
It really goes back to that, to express n qubits, you need 2 to the n complex number. So, if you have 500, qubits, it's really, you just need a lot. There has been some, that being said, there has been some work on how to make the simulations more efficient. Like say, if I have those 500 qubits, that's a whole lot of complex numbers. But if it's really, it's in one state only, they're all zeros, you can express that much more compactly than, all those complex numbers. So there has been some work going into that. I didn't really try to focus on making my simulation, efficient or optimal for those cases, because really when it boils down to it, in the worst case, it's still, you get that exponential slowdown. And really it's those, kind of worst case classically, but are really the interesting problems to solve. Having your 500 qubits be zero really isn't all that interesting.
What about other applications outside of factoring? Are there any that are prominent?
I would say the unsorted search is the other big one, and then just simulating any quantum system in general. So protein folding or applications there, and so on and so forth. But as far as that's really, protein folding is more of a simulation of a quantum system, but as far as like algorithms and kind of perform these tricks you can't do classically, really right now it's only factoring and the unsorted search that are kind of the two big ones that have practical uses. There's other ones, but are more tricks, hey, you can't do this classically kind of a thing.
Do you know of any sorting algorithms that are quantum?
No, I do not, just the searching. Kind of like what I had mentioned earlier, there's really not a whole lot in the way of quantum algorithms right now.
Excuse me.
Where do you think, if you were trying to project, or if you wanted to come up, decide the next thing you want to do was create an algorithm or a quantum machine, what kind of domain or direction do you think is kind of the next natural step beyond what's been done in terms of algorithms?
I didn't focus too much on algorithms, and there's been a lot of people looking into them, but really it kind of boils down to the factoring, I say, where you have all these possible answers, and you need just one. So any sort of domain like that, but really, myself included, a lot of people have a hard time kind of grasping how that quantum computer works and how do you exploit that, because really the factoring is just a little bit of number theory, but someone had the insight to say, oh wow, hey, you could do that part on a quantum computer and then obtain the answer.
What was your motivation for selecting this topic?
That's a good question.
Lots of beer.
Yeah, actually for a living I write web services and stuff. I don't touch any of this professionally. I really wanted something that was, good 10, 15 years out, where there would really be the, kind of the